Hello, my name is Zach Gibbs, and I'm a content developer within education services inside Juniper Networks. And today we will be discussing the DiffServ-Aware TE MAM Learning Byte. All right, so here is the example. In this example, I want to focus right now on the topology that you see. And in this topology, we have 4 provider edge routers and 3 core routers. Those 3 core routers are P1 through P3. The 3 edge routers are PE1 through PE4. Okay, so what we want to do here is we want to configure 3 LSPs using the MAM bandwidth model for DiffServ-Aware TE. And the first LSP we want to, well, it's going to be called PE1, PE3 data, and it's going to belong to CT0. It's going to need a bandwidth reservation of 900 megabits per second, and it will have a priority, a setup priority of 7, a hold priority of 7 as well. Then the next LSP is PE2 to PE4 data. So it's another data LSP. That's going to map to CT0. It's going to need 100 megabits per second, and the priorities are 7, 7, just like that last LSP. Okay, so then the very last LSP is PE1 to PE4 voice. So this is a voice LSP, and we are mapping that to CT1. It needs 100 megabits per second, and it has a setup and a hold priority of 0 and 0. Okay, so the first thing that you might notice here is that with the priorities, the data LSPs get a priority of 7 and 7, which is the least preferred priorities as far as setup and hold priorities. And then the voice LSP gets 0 and 0, which is the most preferred. So keep that in mind. That'll play a big role in what happens in our network. Okay, so the next thing I want to point out is the bandwidth reservations, that dialog box on the right. It shows CT0 has a bandwidth reservation of 900 megabits per second, and CT1 has a bandwidth reservation of 100 megabits per second. So the thing you might notice here is that first LSP needs 900 megabits per second. The second LSP only needs 100, but that's more than that reservation is allowed across any link. So we'll see what happens with that. And then the voice LSP, which is mapped to CT1, needs 100 megabits per second. We have 100 megabits per second available. So keep that in mind. The other thing is all links are 1 gigabit per second links. So yeah, keep that in mind as we configure this. And so let's go ahead and jump right to the CLI. All right, so here is the CLI for PE1. Now, the thing I do want to point out is we will be working within the CLI of PE1 and PE2, but no other routers in the topology. It would be way too much time to try to go through and configure everything. So everything else besides PE1 and PE2 are already pre-configured, so keep that in mind. Okay, so let's jump into configuration mode. And I do want to point out that class of service is already configured. And that's very important because what DiffServ-Aware TE does is it ties class of service and MPLS together. So keep that in mind, that's very important. But it's configured in such a way that class of service is configured, that is, that CT0 receives 900 megabits per second and CT1 receives 100 megabits per second. So just keep that in mind. We don't really need to go into the class of service configuration, nor do we have time to do that. Let's go ahead and jump into MPLS, the protocol configuration. We can see here there's not much configured, just the one interface participating in the protocol. So what we need to do is we need to configure this device, PE1, to use the MAM bandwidth model. Do the set DiffServ-Aware TE bandwidth model and MAM. That's it. And then we need to set the custom TE class matrix. Now we could use the default, but the default's not going to provide what we want. There is a default TE class matrix, but we need to configure a custom one. If I can remember what that is, TE class matrix, there we go. Okay, so then after that we need to specify a traffic engineering class. And we have 0 through 7 that we can configure. We're just going to configure 0 to go to the traffic class, use CT0 for that, and we're going to have priority of 0. And what this means is any LSP that is mapped to CT0 with a priority of 0, it will be a part of the TE0 traffic engineering class. And then after that, we need to configure TE1, set that to CT1, priority of, oh, I did that backwards, nice, priority of 0. Okay, so I need to have TE0 be a priority of 7. Let me fix that. Okay, great, so TE0 is a priority of 7. That will allow those 2 data LSPs to be mapped to that TE class, and TE1 has a priority of 0, which means they'll allow the voice LSP to be mapped to the TE1 traffic engineering class. Okay, great. So let's go ahead and commit that. I do want to show the traffic engineering database, what actually shows up in there when we do this, because now it's participating in MAM. or the MAM bandwidth model, we'll be able to see the information that is in the traffic engineering database. Right, so let's look at that. And what we need to do is, or the thing I want to point out is that the traffic engineering database, a copy of the exact same traffic engineering database, is on every router that is a part of this MPLS domain. So keep that in mind. It doesn't matter where we look, as long as we look for a certain router in the traffic engineering database, a certain link that is, as well as that certain router, will be okay. Okay, so where do we want to look? Let's look at P1. P1 is where the LSPs will diverge and go their different ways. So P1's a good candidate for that. So let's enter the router ID of P1. We need to use the extensive command to be able to find the information we're looking for. And what I like to do, I like to use the find on the end, which allows us to look at the individual links. So we'll start at the individual link. So this link, the 172.16.10.1, is the link that goes from P1 to P3. And that's going to be the shortest path through the network. And so that's what the LSPs are going to want to take if they can. Okay, so looking at this, we can see some information. First of all, we can see the different bandwidth allocations for the CT, or the class types. We see CT0 gets 900, CT1 gets 100. That's great. Okay, so how does that translate to the traffic engineering classes? Well, right above that, you can see that TE0 has 900, TE1 has 100. Perfect. That's great. So let's go ahead and configure the first LSP. So the data LSP, and this is going to P3, so that's going to be, say, 210.10.100.3, and then we can say priority. We want to set this 77, and then we specify the bandwidth needs to be CT0. That's where you specify the CT or the class type, and we want to set the bandwidth to 900 M. So that's 900 megabytes. Go ahead and commit that configuration and see if it comes up right away. And it is up, and we look at the detailed information, we could see that it is taking that shortest path. You can see the second hop for the ERO shows 172.16.10.2. So 10.2 would be the IP address on P3 for that shortest path between P1 and P3. So great, that's doing that. Now let's look at the TED again. Okay, so here we can see some things have changed. We see that it shows CT0 has 900 megabits per second. That's just the static bandwidth that is assigned. But we can see that TE0 has 0 bits per second available. And that's because that LSP requested 900 megabits per second. Okay, so let's jump to PE2, configure this, jump into protocols MPLS. We can see that we already have the DiffServ TE stuff configured, and that's great, that works well. So let's configure the LSP we need here. So this is going to, what is it going, PE4. So it's going to be 10.10.100.4. Set our priority of 77. Then we need to use bandwidth, CT0, 100M. So what do you think is going to happen? Do you think it'll take the shortest path? Try to take the shortest path? They both have the same priority, so they can't preempt each other. Let's go ahead and commit that. See if the LSP is up, and it is up. Let's look at detailed information. And we can see that, look at that second hop, it's 172.16.2.2. That's the path going towards P2. So it's taking a different path. And that's understandable. We jump back to PE1. We look at that shortest path link, and we can see that, yeah, there's definitely no bandwidth available there. Nothing available in TE0. Now let's look at the next shortest path, or the other path. And we can see here that TE0 has 800 megabits per second available. Now that makes sense because that LSP we just configured on PE2 needed 100 megabits per second. And so we've reduced the available bandwidth in TE0 on the link between P1 and P2 to 800 megabits per second. Okay, great. Okay, so on PE1, we have one LSP configured. Now let's configure the voice LSP and see what happens. Which path do you think it's going to take? You know, ask yourself that right now. Is it going to take that shortest path, or is it going to take the longer path? Let's find out. This is going towards PE4. Set the priority to 0, 0. Remember, this can preempt the other LSPs. It is set to 0, 0. This is going to CT1, 100 megabits per second. Go ahead and commit that. See if it's up. It is up. Let's look at the detailed information. And if we look at the voice LSP, it is taking the shortest path. It is 172.16.10.2. That's the shortest path. That means it's taking the link between P1 and P3. Okay, so let's look at the TED database for that shortest path. And we can see here, okay, how did it change? Beforehand, if you remember, TE1 had 100 megabits per second. Now TE1 shows 0 bits per second available. And that's because it was assigned, since that LSP was mapped to TE1, it used the bandwidth available in TE1. And so there was, on this link between P1 and P3, there was 100 megabits per second available. And so it's going to use that in the TE1 traffic class. Okay, so let's look at 2.1, sorry. Okay, we'll look at 2.1. It shows we still have what we had before. 800 megabits per second TE0 and 100 megabits per second TE1. And that's perfect because nothing else new went across that link. All right, so that brings us to the end of this learning byte. In this learning byte, we discussed how to configure DiffServ-Aware TE LSPs using the MAM model, and that stands for Maximum Allocation Model, if you didn't know. And we demonstrated how to verify DiffServ-Aware TE LSPs using MAM model with the TED. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.